Welcome to the video about the RC time constant. What we will see is that the amount of time to charge a capacitor is directly related to the resistance that is impeding the flow of current into that capacitor. What's very interesting is that the one time constant that we need to know is actually equal to the capacitance times the resistance. Therefore, if the resistance goes up, so does the amount of time for us to charge a capacitor. If the capacitor goes up, so does the time to charge that capacitor. So, either the resistance or the capacitance, if it fluctuates, it will definitely have a change on the time constant. Now, to fully reach our full charge, it takes 5 time constants to reach about 99% of full charge. What that equates to is that for every time constant, the capacitor will charge to 63% of the remaining voltage applied, such that if we have 10 volts applied, and let's just say for some crazy reason we have a 5-second time constant. What that means is that in the first 5 seconds it will rise to 6.33 volts. Now the remaining 3.777 volts, we must take 63% of it, and that is how much more will be gained in the next 5 seconds. And the remaining voltage from that, we take 63% of it, and that's what will happen in the next 5 seconds. And as you can see, the closer we get to 5 time constants, that the greater the amount of charge that will be on that capacitor. Now, this works in both directions. So if I want to charge it, I have an RC time constant, and so maybe I want to charge something very quickly, and I have a 100 ohm resistor feeding the capacitor. It will charge very quickly. But if I want to discharge over a long time, I may switch the lead of the capacitor, switch it manually with a wire or with a switch or through some other active component, and maybe switch it to a 1 megohm resistor. And obviously that much higher resistance is going to increase the RC time constant and therefore let it, what we call, bleed for a very long time. So, larger resistance, larger time constant, larger capacitor, larger time constant. And once again, it works for either charging or discharging of the capacitor. Now, watching the signal on the scope, what you will see is that the voltage will increase over time. And what you want to do is make sure that you mark your spot here on the curve and start there, and then figure out the amount of time and look at one time constant and make a measurement at the voltage right here, and then do the same for the 63% remaining, and then a 63% remaining, and a 63% remaining. And as you can see, pretty soon we're going to be pretty much even, and that is going to be our supply voltage going to it.